Hello, my name is Claire Stewart and I am a Product Manager for Imaging Software with PerkinElmer. In this tutorial, we will look at how to perform advanced analyses in the Volocity 3D image analysis software in order to extract the most information from your image data. Volocity allows you to gain a full picture of your biological process of interest with rapid, interactive, high-resolution volume rendering of time-resolved multi-channel 3D datasets. Stunning images can be prepared for publication and compelling movies can be produced for your presentations. However, 3D images and movies are only part of the story. We also need to extract numerical data and then explore that data to draw conclusions and fully test our hypotheses. Packages such as Excel are used a lot for this, but some jobs are quicker and more easily achieved using the specifically designed analysis tools in Volocity. In the Measurements view, measurement protocols are created to automatically find populations of objects and record properties of those objects and the relationships between them in tabular form. This table can be viewed in the Measurements view and exported from here. Tasks possible in the Measurements view are covered in several of our other tutorials. The table can also be extracted to another item in the library, called a measurement item, where we can continue to work with the data. Let's look at this in more detail. In this first example, we're looking at an experiment in which the properties of two probes, marking points of interest within the nuclei, were measured. I will use this to illustrate the use of the analysis view to get not only counts of the number of probe locations per cell, but also the mean intensities per probe colour per cell. The objects, which in this case are nuclei, have already been found, and the red and green probes compartmentalised within the nuclei. This is essential to generating our per nuclei measurements. The first step is to make a measurement item. From the measurement menu, select Make Measurement Item and choose to make a new item. The measurement item is added to the library below the relevant image sequence. Click on the measurement item to view it. We can see that the mean intensity of each focus detected is shown in the relevant column. Click on the Analysis tab. From the Analysis menu, select Analyze. This is where we're going to choose what to display, how to summarise it, and to show what it varies with. As a reminder, here we are interested in counting the number of foci and determining their mean intensity per nucleus. As we want per nuclei measurements, we need to restrict the analysis to nuclei and contained objects. As we're analysing the mean intensities of foci in two channels, FITSI and Texas Red, the data mean FITSI and mean Texas Red is selected. Hold down the Control key to select multiple items from this list. We then need to summarise the data by mean and count. Finally, to show the mean intensity of foci per nucleus, we need to organise the data by the compartment nucleus ID. Click on OK. The resulting table can also be exported in an appropriate format for further use in packages such as Excel by right-clicking on the measurement item in the library. In the second example, shown here, we have time-resolved data where the intensity indicates changing activity over time, and we want to know by how much. The absolute numbers alone do not provide much insight. Instead, the normal approach is to normalise the data, and that too is possible with Volocity. Here, all the time points have been measured and are included in the measurement item. In the Analysis dialog, we first set up the basic analysis to show the mean intensity of the data at each time point. Then, in the Normalise tab, we set the time point to be normalised too. Since the time data is represented in the rows in the table, we normalise to data in a row, and in this case, the first row. For more information on any of the tasks shown in this tutorial, or if you would like more information about Volocity in general, please contact one of our imaging specialists.